line symmetry. For the sum of the figures, take the line segment which is 10 centimeters and name it as AB, and using point A make an arc by taking more than half radius. Using A we made an arc, and using A we made another arc and down of the line segment. Now use the point B, cut this arc and this arc. So we got two arcs and join these two arcs with a line segment. So we draw a line segment, and this is nothing but perpendicular bisector. We have already learnt in constructions. So this is the perpendicular bisector of AB. So we call this perpendicular bisector because it divides into two equal parts. And if you take this point as O, O to A is 5 centimeters and O to B is also 5 centimeters. So it divides into two equal parts. So what we have drawn the line, that is called as line symmetry. And we draw a line symmetry for a line segment for one, and we take an angle, next one. So we have drawn a perpendicular line for a line segment which is 10 centimeters. So this is called line symmetry. So it has only one line symmetry. If we try to draw the perpendicular bisector for it, so there is no other line we can draw as a perpendicular bisector for this diagram for line segment. So for this one bisector we have drawn. For bisector we can draw one line of symmetry. For example, we have taken any line segment which is 10 centimeters, and then we draw along with a point, particular point we have taken which is in between the line segment, that is 5 centimeters. We have taken one point. So along with this point we draw any other line, and this line also will divide the line segment into two equal parts. We can take another line which this line also will divide into two equal parts. In that way we can draw infinite lines for this line segment. So that what we understood from here, from this, so a line segment has infinite lines of symmetry when we draw in this manner, but when we draw perpendicular bisector then it has only one line symmetry, and along with the bisector we draw in other methods like divide into infinite lines of symmetry. Now let's take an angle. We have completed a line segment. Take an angle. We constructed an angle. Name it as AOB. Angle AOB is one of the angle. We know that how to construct an angle bisector. We have learnt in constructions. So take a compass using O. Let's make an arc using 1 or 2 centimeters. As per our convenient, we have taken 2 centimeters radius, and using the point O we made an arc. So we got 2 points here. This is point 1 and point 2. Using the point 1 make an arc again. Using the same radius we can take, and using the point 2 make an arc, and we use the 2 centimeters radius using the point O, and we made an arc, and we got 2 points here, 1 and here 1, and again use the point 1 and make an arc, and also use the point 2 make an arc, and these two are intersecting at point, one of the point that is called as 3. So now take a scale and join the point O and 3. So So we have joined point O and 3. So this line will divide the angle into two equal parts. This line whatever we have drawn with the dotted line, it divides the angle into two equal parts. So this is called as line symmetry for an angle. So here angle AOB is divided. Let's take here C. So angle BOC is equals to angle AOC. Here POC is one of the angle and which is divided after division. POC, one of the part of the whole angle, and next part is angle AOC. And when we measure these two angles, this both will be equal because OC as bisector for angle AOB. So this is the line symmetry we call. Let's take another figure, that is isosceles triangle. Then after we'll take equilateral triangle. We take an isosceles triangle. Already we have learnt in triangles, and the triangle which is having two sides are equal, and then we call it isosceles triangle. And these two sides are equal. So let's see. These are two equal sides, and this is a side which is not equal to other two sides. One is different and two other are equal. So from the equal sides, opposite sides, which are two equal sides, along with that, the middle of the equal sides, we draw a line which is perpendicular to the opposite side. We draw a perpendicular line towards the third side. Then we get a line which will divide into two equal parts. Let's see. This line will divide the triangle into two equal parts. So this line is called line of symmetry for an isosceles triangle. So this is for isosceles triangle, only one line symmetry can be drawn for an isosceles triangle. Now let's take an equilateral triangle. We have learnt in triangles, and all the three sides are equal and equilateral triangle. All the three sides are equal. So let's see here. A triangle has three vertices, and this is an equilateral triangle. For an equilateral triangle, how many lines of symmetry we get is, along with the vertex, we draw a perpendicular line towards the opposite side. We get one of the line of symmetry, and then the next vertex, we draw a perpendicular line through the vertex. We draw a perpendicular line towards the opposite side to it. Similarly, we draw for this vertex also. Then we get three lines of symmetry for an equilateral triangle. So let's draw a scaling triangle. A scaling triangle. All the three sides are equal, we know that. So here we take an scaling triangle. As a scaling triangle, three sides are unequal. So all three sides are different in this. Then we try to draw a line of symmetry for this. So along with the vertex, one of the vertex we try to draw, but this line will not divide this triangle into two equal parts. It doesn't equal. So this is not the line of symmetry. Along with this other vertex you draw, and also it is not equal. We try to draw an line of symmetry for isosceles triangle. So we don't get any lines of symmetry for this. So there is no line symmetry for scalene triangle. So let's go to the next concept, the square. Let's take a square. We know that we have learned the properties of a square. All the sides are equal. So all the sides are equal. And then we draw a line. We take a midpoint and draw a line along with a particular path. Then it divides the square into two equal parts. And we can draw horizontal also. So this line also divides the square into two equal parts. So we can draw diagonally. This will divide into two equal parts and also another diagonal. So here we observe that four lines we have drawn. That four lines are drawn here on the square and will divide the square into two equal parts. So there are four lines of symmetry for a square. Let's take the rectangle now. For a rectangle, along with the particular path, we draw a vertical line. It divides the rectangle into two equal parts, and also the two parts will coincide each other. And horizontal also. And this also will divide into two equal parts, and the two parts coincide each other when we fold that figure along with the line. So here we got two lines of symmetry for a rectangle. When we try to draw along with the diagonals, along with two opposite vertices, it divides into two equal parts, but the two parts will not coincide each other. So there is only two lines of symmetry for a rectangle. So let's take next concept, next figure, that is rhombus and kite. We know that rhombus is a figure which is having all the sides are equal. And this all the sides of rhombus are equal. And kite is that adjacent sides of the diagram are equal. Only adjacent sides are equal in this. So when we try to draw a line of symmetry for rhombus along with opposite vertices we draw, and this is one of the line symmetry. And another opposite vertices, next line of symmetry. So here we got two lines of symmetry. And take kite. Here we can take this opposite sides, opposite vertices. We can observe that there is these two parts, that is acute angles opposite each other. And then we divide that opposite vertices along with this line we draw, and this is line of symmetry. and when we try to draw horizontal, this part is small and down part is bigger than this upper part. So we cannot draw the opposite vertices of horizontal line. So it will not be equal. So we can draw only one line of symmetry for a kite. So let's go to the next concept, that is isosceles trapezium. So isosceles trapezium is nothing but which are non-parallel sides of trapezium are equal. These are non-parallel sides of trapezium. Parallel sides are these two, opposite to each other. These two are parallel sides and these two are non-parallel sides. Non-parallel sides of trapezium are equal. Then we call the trapezium as isosceles trapezium. Let's take isosceles trapezium as ABCD and take this isosceles trapezium and draw a midpoint of this along with the particular path. Then this line will divide the trapezium, isosceles trapezium, into two equal parts. There is only one line of symmetry for isosceles trapezium. We'll go to the next figure, that is circle and semicircle. We'll take a circle and we draw a line along with the center of the circle. It's called a diameter. Another line to the center of the circle and another line. We take another line to the center of the circle, and similarly we can draw infinite lines through the center of the circle. So there are infinite lines of symmetry for a circle. So let's take a semicircle. A semicircle is taken. Through the center of the semicircle, there is only one line can be drawn, and which will divide into two equal parts. So there is only one line of symmetry for semicircle. So these are the figures we have taken, and we've drawn lines of symmetry for all these figures.